Apparently I've decided to write in child size up here. So number 21 in 14.5 says I have a function of 3 variables, x, y, and z, and that's equal to x times y plus z squared. And I'm supposed to calculate a directional derivative as I leave the point 1, 1, 0, and I head to the point 0, 1, 1. Cool? All right, so what do I need? How do you get a directional derivative? First off, I think I should be doing f something of x, y, and z, right? Maybe notationally that should be f in the u direction. So how do I calculate that, and what things do I need? I need a gradient. Okay, so I'm going to take the gradient of f, and I'm going to evaluate somewhere, I guess.
Which one would you use though? I know it matters.
I'm guessing your starting point with u being ready? Or?
Yeah, so this really should be evaluated somewhere, right? Otherwise, fu of x, y, and z is like function object,
It's another
right?
function, yeah.
Yeah, and I really would like that to be a scalar. So first things first, I need to figure out where to evaluate this sucker. So where am I standing?
1, 1, 0.
Yeah.
So I'm standing at 1, 1, 0, and I'm looking in the direction of 0, 1, 1. So here I am, looking that way. You guys all good with this? So I should be evaluating these at 1, 1, 0. 1, 1, 0. And I better be dotting with, ooh.
I read online it's a normalized vector.
Good.
The other point.
This should be a vector that just gives you the direction information, right? So I need to know what the vector is that gives me this information, right? These two things aren't vectors. These are points. Right? I'm standing on a point and I'm looking at this other point. So I need a vector that gets me from there to there.
-1, 0, 1?
So that would be that thing minus this thing, terminal minus initial. So this would be the vector, this minus that seems like -1, 0, 1. You guys cool with that? So when you're calculating displacement vectors, it helps to remember the phrase terminal minus initial.
That'd be the difference then with the other one.
So yeah, the other one, right, so in the next problem, you're coming the opposite direction. And so you do the terminal point minus the initial point, and it gets backwards. All right, so I got a vector, but how long is this vector? Good. Who said that? Perfect. Thank you. It's Anthony, right?
Yeah.
So more than one is all that matters. Specifically, even less specific. That's a fun sentence. Even less specific, what would the right answer be? How about not one? If it's not 1, you got some work to do. You guys see that? Because this should be dotted with the vector u, right? But I think we need to think about that vector u, and that needs to be what? Yeah, it's got to be a unit. If it's not a unit, you can't play this game because you're adding this direction or this magnitude information in here, and frankly, we don't need that. You guys see that? Because looking in the direction of 0, 1, 1 is the same thing as looking twice as far, right? Like I could look past it and that would still work. But the hill should have the same slope regardless of where I'm looking. You guys see that?
Okay.
Okay, so how do I strip the magnitude information off of this thing?
The square root of all of those squared.
Cool. Calculate the length. So this thing is the square root of 1 squared plus 1 squared plus 0 squared is 2, I think. Okay, so this is root 2 long. So to actually calculate f u at 1, 1, 0, I need the gradient, which I still haven't calculated, right? And then to evaluate it. But now I need to dot with
Vector times the length.
good. The vector negative 1, 0, 1.
Times root 2. Or dotted, would it be dotted with root 2?
No. It's divided though, right?
It's divided by root 2.
Why is it divided by root 2?
Then it would equal 1 because it's like
Yeah, so
magnitude.
this thing is root 2 units long, right? I need it to be 1 unit long. So I'm just going to slash its length by a factor of root 2. Like if it was 2 long, right? I'd have to divide by 2 to get it to be 1 long. It's some annoying length, but you just divide by the length. So that's true in general, right? If you want to make a unit vector out of anything, you just do v divided by magnitude v. It's kind of bad notation to write a vector. We do this all the time, but really this is like scalar division, right? You guys all see that? I never really told you scalar division was an operation, so I kind of lied to you a little bit. It's fine. Just do it. So now what else did I need here? I needed,
Gradient.
yeah, I better get the gradient of f so I can evaluate it at 1, 1, 1. Okay, so gradient of f as a function of x, y, and z, right, should be,
Y, X, and 2Z.
seems like y, x, and 2z. And then I need to evaluate that at,
Point you're going to. No, the point you're already at.
the point I'm already at, right? Where you're standing is where that hill matters, right? The hill could look totally different over here. So we need to get, let's see, evaluate at 1, 1, 0 gives me 1, 1, 0. That's weird. This is a vector though, not a point. You guys see that? And then I'm dotting with the vector negative 1, 0, 1. And then I need to, what was this operation again? I'm somethinging 1 over square root of 2. Yeah, that's really me unit vectorizing. That's like scalar multiplication, right? Okay, so what do you get out of this thing? It's like equals number, right? So I got negative 1 plus 0 plus 0. And then all of that times 1 over the square root of 2 gives me negative 1 over the square root of 2. Which tells me that it is what? In the direction I'm looking. Yeah, downhill, whatever hill means in this situation, right? You guys see I've got a function of 3 variables, right? Okay, so that takes a point in 3 space and makes some number out of it. Go-to example for things like this, just temperature in the room. Okay? So this tells me that if I'm standing here at this 1, 1, 0 point, right? And I'm looking at the point that's, let's see, 0 over, 1 back, 1 up. So I'm like looking back over here. You guys see that?
It's not uphill though, it's
plus 1 in the z direction.
Yeah, so again, it's not uphill because hill doesn't make any sense here. But it's colder if I look that way.
Okay.
You guys see that? It's the response that's changing by -1 over root 2 for every unit I go in that direction. You guys see that? So yeah, it's hill doesn't make any sense here because this was already a function of 3 variables. Whereas usually I'm doing like f of x and y, and then hill makes total sense. Yeah, it's temperature or something. Or the density of the air is getting lower in that direction or something. Or the concentration of poison gas is going down. Whatever.
My big confusion with this problem, I got the right answer, but I wasn't sure if it was like a fluke or not. I did the partial derivative for x, y, and z. I plugged the point in, or I subtracted the 2 points, plugged those values in, got a -1, and divided by the magnitude, I got a -1 over root 2. And I thought that was right. He said that that was just an accident, but I guess would that work everywhere? If I took the point you're going to minus the point you started from, plug those points into the partial derivative? Okay.
No, you just got lucky.
I guess I'm just not recommend.
Yeah, so this thing was a little weird, right? That the gradient, when I evaluated, was the same factor.
So that's not always going to happen.
The probability of that happening at random, like if you pull a function out of the world and a couple of points and do this, yeah, that's probability 0. It just, this kind of stuff happens a lot when we deal with little numbers, right? Like at the beginning of this problem, basically everything here is either 0 or 1, right? And so coincidences are pretty possible. Right, like all through this problem, you could actually interchange the role of x and y and nothing would happen. You all see that? It's totally symmetrical in x and y. Can I do that in general? Hell no. Cool. Questions on the rest of this? Who's good on this one?